Okay, hello everybody, good morning. So today we're going to talk about loops and exceptions and more if we get time. So as before, as every day from now on, just run this first, set server output on, and also run this new statement, set verify off. Because when we use substitution variable, it may show you the code as the output, but we don't want that. So we don't want to see the code again and again. And substitution variable. So we had an example before. Remember, we had this example that we just counted the number of employees in each department. In a department, and we sent this message, we showed this message that the department blah has less than 2 employees, or we showed the other message that says name of the department is this. So if the department has 2 employees or more, it shows the name of the department. So there was a problem with that. The problem was that we had to change the code for every department. So the department number was a constant. And here we have 4 as a constant, as the department number. So I'm running that. I'm running the code. It shows, it runs the code for just department 4, and it says name of the department is personnel because department number 4 has 2 employees or more, right? Okay. So if I want to know, run the code for department number 3, I should change the code and make it 3 and run it again. So this is stupid. You shouldn't do that. You can do better. So we use substitution variable instead. Substitution variable, when we put and sign, and then we put a statement for name of a variable. Actually, it is not a variable. It is just a name that the user sees. It prompts the user to insert a value. And this is the prompt that the user sees. Enter value for the department. The department was the statement in front of and sign. And now I can say, okay, the department number 6. And it runs the code for department number 6. So I want it for department number 2. It runs the code for department number 2. And that is the use of and sign and actually substitution value, right? However, you should keep that in mind. This is not a dynamic substitution. So what Oracle does actually is that when you run the code, Oracle scans for substitution variables anywhere in the code. Okay? And prompts the user to put value for the substitution variables anywhere in the code. Okay? Then what it does is that it replaces your value. It replaces this word, whatever you have in front of and sign, with your value everywhere in the code, and runs the code only once. All right? So it doesn't ask you about the value of the substitution variables in the middle of the code. It asks about the value of the substitution variables at the beginning of the code for all the substitution variables. Okay? So this is an example, and as you know, if there is an exception, if the department number that you put has more than two employees or more, but it does not exist in the departments table, it should give an error, and it shows you an error. This is the error that it shows. Okay? So, do you want to see another example? Yeah? Okay. So, let's see another example. I'm gonna give you a very easy and simple example, so you know what it is. DBMS output. Oops. So I'm going to divide 100 by the number that the user gives. So user number and show the result. This is the shortest code ever. The user gives a number, let's say 4, and 100 divided by 4 is 25. So that's how it works. So it prompts the user to insert a number and then divides 100 by that number and shows the result. Okay, so we are going to work on this example a little bit more in a bit. So I'm going to run this code, and instead of a regular number, I'm going to put 0. So it gives an error like this, very ugly error. We should handle this error. So keep that in mind. But now let's work on if, else statements. So remember, at the end of the session on Monday, we talked about if, else if, and we didn't have any example, but now I'm going to give you a very good example. So let's start with the book's example, which is the harder one. So in this example, we define this variable, a date, first invoice due date, and we go to the invoices table, find the minimum invoice due date in the invoices table, and insert that minimum into first invoice due date. Okay, into this variable that we define. And we are only considering the invoices that have a positive balance. So that is just something that we are considering here. And then we use this variable like this. If this variable is less than sysdate or less than today, that means it is before, the due date was before today, it shows invoices overdue. If it is equal to today, so else if it is not before today, but it is equal to today, then it shows invoices are due today. It shows this message. And else, it shows no invoices are overdue. Else means none of the above conditions hold. And that means the due date is after today. It is more than today, more than sysdate. And if. So when you run this code, it goes and finds the invoices and shows this message, invoices overdue. So the minimum is overdue, apparently. And if I put max, probably it should not be overdue. It is still overdue. So actually all the invoices are overdue. They are past the due date for all the invoices. So that's how it works. So if, else if, you can have as many else if as you want. Okay? So it checks the condition, runs the code if the condition is correct, if condition is true. If it is not, goes to the next. Then goes to the next. So it goes until it gets to a condition that holds, and then runs the code for that condition. Okay? And if none of the condition, if none of the conditions, if none of your conditions hold, it goes to the else, and it runs the statements in front of else. So else means none of the above. Okay? So now do something. It is very simple example, very easy. So you should be able to do it. Ask the user to insert a number, and then show a message based on the number. If the number is negative, show this message. This number is negative. If the number is 0, show this message. Your number is 0. If the number is positive, but less than 100, show this message. This number, show the number, is a small positive number. And if the number is more than 100, it should show this message. This number is a large positive number. Okay? So there are 4 possibilities. There are 4 possibilities. The number can be negative, can be 0, can be positive and small, can be positive and large. And if it is more than 100, we consider it large. Okay? Let's imagine it is price of product. So I don't want you to just select, go to the product table and do it. It is just an easy example. So imagine the user inserts the price of the product. So the price, if the price is negative, so that means that it is negative. So, or balance is better. If the balance is negative, is it is 0, it should show 0, and etc. Do it. So there is no select or any other statements. You don't need to worry about the select statement. Since we don't have much time, I'm going to show you gradually, level by level. Yes, so first, obviously, you should define a variable, the number, because we are going to use that. The number as number, and then prompt the user to insert the number, and prompt the user to insert the number as the balance. So it prompts the user to enter balance, the value for the balance. Then in the code, if the number, because it is the value of the number, if the number is less than 0, then shows this message. This number is negative. If the number is equal to 0, shows this message. Your number is 0. And if it is between 0 and 100, then it's a small positive number. And else is a large positive number. Else, that means if it is not less than 100, and that means it is more than 100. So we don't need to put that condition here anymore. And it is implied. So let's run it. See what gives us. 5. 5 is a small positive number. 2000 blah. 2000 blah is a large positive number. Negative blah. negative 345 is negative, right? Actually, we could do it a little bit better. Else if, I can say else if this number between 0 and 100, then it becomes inclusive, so I don't want it to be inclusive. Let's say between 1 and 99. So it is going to be exactly the same result. Actually, it can be between 0 and 99.
Is it inclusive?
It is inclusive, but it still gives the same result. Why?
Oh, because the else if statement for 0 goes first?
Yes,
Okay.
because it first runs this statement, and if it is 0, it just does it. Okay. So it doesn't come here if it is 0. So it doesn't matter if we check for 0. It doesn't matter if it is inclusive. And essentially, actually, we can do this. We can do this. This is the best way to do it. So else if the number is less than 100. So that means if the number is, if it is negative, it runs the first statement and that's it. If it is 0, it runs the second statement and that's it, and goes. So when we are here, that means it was not negative or 0. Okay? We know that it is positive already. We don't need to check for that. Then else if the number is less than 100, it is a small positive number. And if it is not the case, so we know that it is a positive number more than 100, else, so we don't need to put the condition here. It works like this. So, we learned if else. Now, I want you to do something. We can do this using case. We can do exactly the same thing using a case. And I'm going to show you how to do it. So, remember case, the case statement. So, how did you use it? The case statement? It was like this. The simple, the conditional case. We used case when a condition is true, when a condition, then we would have just some value, okay? We would have some value, and it would return this, whatever we have here, if the condition is true. If this condition is true, it would return what we have here, and if none of them was true, it would return this. And at the end, we would put end. Okay? We'll put end. So, that's similar. However, so the case, the whole case, this case statement would return something, some number, some text, some value, right? It would return some value. And it is interesting that we could use it in selected statements. We could multiply it by something. Okay. However, in PL/SQL, we cannot have just a value or a number hanging out there just in line. In PL/SQL, we have to have execution commands, commands that we execute. PL/SQL goes to execute commands. So we have to have a command here. Okay? So now we have the case used like this. When this condition, execute this command. And this command, of course, it cannot be just some text. It is not a command. It cannot be just 5. 5 is not a command, but this is a command. Variable equals this. Okay, this is a command. or variable equals this. Variable equals this. This is a command. This is the command that can be executed. Okay? But 5 is not a command. Variable equals 5. This is a command that can be executed. This is an executable statement. Okay? But a constant, this is not an executable statement. Okay? So, or a variable by itself is not an executable statement. So, when we use case to execute something, when we use case in T-SQL, at the end we put end case. We put end case. That's we put at the end. And the syntax is very similar to what we had before. And just the conditions are checked and the statements after each condition, after each then, when then, a statement after that will be executed. So now change this into when then, into case when then statement. What we have here, what the program that we just ran, that tested, that checked if the value is 0 or negative or positive, can be rephrased using case when statements. Do it. Change it to do the same thing using case instead of if, else if. So case when is very equivalent to if, else if. They are analogous. They are almost always convertible. They're almost always interchangeable. Almost always. So do it. Question?
I don't know why it's not running.
Oh, which one is not running?
No one from before. We had to create also.
No idea. That's possible. I don't know. So touch after class we try to figure it out. Probably you're missing a semicolon or comma or something somewhere. So, who did it? Nobody? Okay. So let me show you. The changes that you make. You put case here. Okay? Put case at the beginning. And at the end, you have end if, you change it to end case. Okay? This is the next change. And you change every if into when. And if into when, and every else if into when. and then else remains the same, else is the same. Now we have exactly the same thing, and it results exactly the same thing. So instead of if, else if, else if, else if, you have case when.
So in the example, sorry, before that, in the notes, it says like case, then the name of the variable.
Oh, okay, that is the simple form of case. We are using conditional form of case.
Oh, okay.
So the case that doesn't have anything in front of it.
Mhm.
And when the case doesn't have anything in front of it, that means it has true in front of it. Remember? When it doesn't have anything in front of it, that means it implies that we are comparing the statements with true. Comparing every one of them is true. So it means case when this is true, then blah. When this is true, then blah. When this is true, then. So if you run this, you get exactly the same results. So I put this number is a small positive number. I put this number, it is a large positive number. See? So, so case when is absolutely equivalent to if, else if statement. So, now it depends on your taste or which one looks simpler to you. So, who thinks case is simpler? Is easier to understand? Case is easier? Who thinks if else is easier? Oh, actually I agree with you that if else is easier because at least we are using one less word. So, here we have a more practical example. Okay, so here we have the situation where the case is actually the simple form of the case. That it has a number in front of it and we don't have conditions here. So now in this format we have a case, some variable or some number or whatever, something that returns a value, and then when one possibility. Then run a statement. So as before, instead of value, we should put an executable statement in PL/SQL. So in PL/SQL, we always should have an executable statement. And the case should always return an executable statement in PL/SQL. So again, we have an executable statement for each when clause. And in front of each when clause, we have each possibility for the value in front of case. And we have if it is -1, if it is 0, if it is 1, that's it. So it is equivalent to saying that if the number equals to that, it is exactly the same thing. Okay? However, when you have such situation that you have case when a condition that is an equality condition, and then another condition that is equality condition, and then another condition that is equality condition. All your conditions are equality conditions. When you are in this situation, so it is more efficient to put the variable here, and then just put the possible values in front of them, in front of whens. So this is more efficient. But it can only work when you have a finite possibilities, finite numbers, so countable numbers. So if you want to check for if it is between 100 and 200, and it is between 200 and 300, if it is less than 0, it is more than 0, it cannot check for that. You cannot do that here. Okay? It only can check for equality. And as you can see, this is, so if I put 1, it says 1 is a small positive number, and if I put anything else, it says that anything else is a large number. So even if I put 2, it says it's large number. So it can count to 1 just. So that's the two forms of case. That's the two forms that we can use case in T-SQL. So they are analogous to the two forms of case that we used in select statements. Okay, that return values. And except here we put end case at the end. So this is a more practical example, more applied example. We define terms ID variable as a number, and we select terms ID from the invoices. We get the terms ID from the invoices, where the invoice ID is a specific invoice. So for a specific invoice, we get the terms ID and put the terms ID of that specific invoice into terms ID variable. So essentially, the terms ID variable is the terms ID for the invoice that the user enters. Okay? And here we are checking, we are using the case, we are using the simple form of the case to compare the terms ID for that invoice to 1, 2, 3, or etc. If it is 1, it shows this message. If it is 2, it shows this message, etc. And if it is none of the above, it shows this message. So let's say I'm concerned about invoice 94. The due date is 20 days. I'm concerned about invoice number 4. The due is 30 days. So for each invoice, you can get a message based on the term ID of that invoice. So, are we good? What?
How do you, is there a way to make case be false if you put a variable in it? It's like case false.
Case false? Oh, you mean here, case false?
Yeah.
Actually, when I said case true, I said imagine case true. You cannot put true there. And you cannot put false there either. You just imagine that. So the answer is no. So now about error handling. So I'm talking about exception handling here because the syntax of exception handling is very similar to the syntax of case-when statements. So there are many types of exceptions, but I think these 4 types will be enough for us. So invalid number, value error, duplicate value on index, or generally duplicate value, and zero divide. So this is an example that is related to one of the tables. So we don't have any variable, we don't define any variable in this example. We just try to put these values, let's say these values into general ledger accounts. So if you go to general ledger account, it has 2 columns. The first column is a number, the second column is description, is varchar, and this should work. This is number and this is just varchar. And if it works, it shows this message, 1 row inserted. However, there is a problem. If you go to constraints, you see that there are several constraints. One of them is that the first one, the accounts, it's primary key, and the other is that description should be unique. So the description in the general ledger accounts must be unique. That means this should be unique. And when we go to data, we see that the first one is cash. So if we try to insert cash again, we are violating the uniqueness constraint, right? So what we do is this. We put exception, and then when this is the exception, when the exception is this, then show this message. When the exception is this, then show the other. Show, do nothing. So null means do nothing. Then when there is another exception other than the exceptions that we had before, then show the other message. And also show this statement, this text. So SQL ERRM is the text of the last error. If the text, the number of the last error aligns with the description of the last error. Okay? So, so essentially, exception, what it means is this: case error. That's it. It is just trying to see what is the error. That is equivalent to case error. So exception is equivalent to case error. So you have exception, and so if I try to do that, if I try to run this, so if it is a new thing, if it is a new text, it should run and give me a good message that, oops, new error. So, oh, I already have 130, so 140. Do I have 140? No, okay. So, one row inserted, okay? So, it happens when it is successful. It successfully can insert the row into the table. But what if I put it like this? Let's say 130 or whatever. So now it should come here. So it should give an error. So when it gives an error, it doesn't run this the next line anyway. So it doesn't go to the next line. It goes directly to the exception. And it says what is the exception. If it is duplicate value, it shows this message. And in our case, it is actually the case. You attempted to insert a duplicate value. That is the message that you wanted to show to the user. Okay? It is the message that you wanted to show to the user. And the other thing, the other possible error is that you may try to insert a text as a number. We should put a number there. You may try to do that, and if we try to do that, it doesn't do anything. So invalid number, it doesn't do anything. That is what we set it up to do. So it didn't do anything. It didn't show any message. Just ignored the insert command. It didn't insert any row, but it didn't show us any message there. Okay? And there are other possible errors, and if there is any other kind of error, it shows the other message. That's how exceptions work. Now let's go back to our first earlier example. Divide number 100 by a number that user gives. Okay? Divide that by a number that user gives. I'm gonna give this number. Let's say this works. It divides 100 by that. What if I give this number? Oops. What if I give this number 0? Your number is 0. Insert another number. That is the message that it shows when you try to divide by 0. See? What?
So did you just kind of come up with the name 0 divided, or is that like a built-in command?
Oh, the zero divide is actually the name of the error.
Oh, okay.
So there are 4 errors, common errors that we have there. Invalid number, value error, drop val on index, and zero divide.
So that's like built into our PostgreSQL.
What?
Are the names built into the?
Yes, they are built in. They are kind of keywords.
Okay.
So that's about it. And any questions so far? Any question? So we have half an hour. So now let's talk about loops. That's very important. Many times you want to run a code multiple times. So going through the rows in a table, going through different customers, different products, different cases, you know, and you want to run a code multiple times, several times, like insert some particular thing many times. So you want to run insert multiple times to insert different rows, and for that you should use one of the loop statements. So the simplest one is this, loop and loop. Okay, so I don't think it is very clear here, so I'm gonna type it again. So okay, I'm gonna write it again. So it works like this: loop, statement, executable statement, executable statement, and then you have and loop, right? So what Oracle does is that it goes through the statements, runs them, and then when it reaches here, it goes back, runs all the statements, goes back, runs all the statements, goes back, and does it forever. Okay? And we normally do not want anything to run forever. Okay? We normally do not want that. So we normally, when we have this thing, loop and loop, we usually should have something like this: exit, an exit clause, an exit clause. Exit when condition or exiting condition. Okay? So this is the exit condition. So it runs until this condition becomes true. Once this condition becomes true, when it reaches this line, if the condition is true, it jumps to the next line after end loop. It jumps to the next line after the end loop and exits the loop statement. So this is a very simple example. We are going to count from 1 to the number that the user gives. So the user gives 198. It's going to count from 1 to 98. See? It is counting from 1 to 98. Count from 1, counts from 1 to 98. And that is how it works. However, we can rephrase this in another form, and that is using a while statement. So, while statement is like this. So, while statement runs the statements inside the loop until the condition holds. So the while condition, so when we have a while condition, So loop, we go here and loop, and it runs the statement inside while multiple times. So what it does is this: it checks the condition. If the condition holds, it runs all the statements, then comes back, checks the condition. If it is true, runs all the statements, comes back, and it runs it until the condition becomes false. Okay? So, the difference between while and loop, there are two differences between while and loop. The first difference is that loop runs until the condition holds. So when the condition becomes true, it exits. But while runs until the condition holds, and when the condition becomes false, it exits. Okay? There is another difference. While can run the statement, all the statements, no time. So it is possible that while does not run any statement at all. If the condition is false from the beginning, it just doesn't do anything and jumps to the end. Okay? However, loop is not like that. Loop runs the statements at least once. It should run the statements, then it can check the condition and exit possibly. So it runs the statements at least once. It runs them at least once. And so this, I think, yeah, we have this. So this script does exactly the same thing that the loop did before. So we have we define I as number that starts from 1, and we have while I is less than or equal to the user's number, and it shows the I counting from 1 upward. So it adds 1 to I every round. So I'm gonna give, let's say, 5 and 1, 2, 3, 4, 5. It counts from 1 to the statement that we had. And what if I give it -6? Does nothing. What? Ooh. So again, if I give it 6, it runs 1, 2, 3, 4, 5, 6. If I give it -6, it does nothing. It doesn't run it even once. Okay? However, here it is not the case. If I give it -7, let's say, it runs it once. It runs it for I equals 1. Because it is loop on loop. It should at least run it once. Okay? So far so good. These examples are very particular cases. Actually, in practice, we usually use while and loop when we have a more complex condition, not counting. Okay? So we have a condition like if the customer, as long as, so while means as long as the customer is in California. So it just goes through the customer supply in California. Or as long as, I don't know, the price is more than blah. So if it is sorted by price, it goes up to the point that we have the prices that are more than $200. Okay? But when we are counting like this, because it is just counting something, from counting I from 1 to user number, it would be more efficient to use for loops. For loop is a statement for counting. It is very efficient. So what it does is this. For I in a set, here you define a set, so I can define a set like something like this. Define a set 1 to 7. Okay? So it means 1, 2, 3, 4, 5, 6, 7. It is inclusive. but I'm going to define the set 1 to user's number, whatever number the user gives, loop, and then the statement inside the for loop, and then at the end we have end loop as always. So you see, always we have end loop at the end of each loop. So if I run this, it gives exactly the same thing. So I'm going to say 9, so it says 1, 2, 3, 4, 5, 6, 7, 8, 9, and it runs it 9 times. However, as you can see, it is a way shorter code. The code is much shorter because first of all, we don't need to define a variable. I is just defined in the for loop, and we don't need to have if statement. We don't need to have, because in loop we needed to have some kind of if statement, exit, and the condition, you have to have a condition here. But here we don't need to have a condition because condition is implied by the ending value. So this is another example. So you can put set in front of that generally, but we don't have time for that. I'm going to just show you a more advanced example that is using cursors. So I need to teach you cursors because they are very important. So cursor is a kind of table, but it is not table. You may confuse it with table because it is a set of rows. However, what cursor is actually a vector of rows, or a set of rows actually, a set of rows. It is not a table. It may look like a table, but it is not. So what we do with cursor is that we use it in for loops. So first of all, let's see what we have here. Remember, we could define the type, the data type for a variable using the data type for another variable. Remember? So we could have, let's say, the number is number, or we could say the number is invoice total, whatever it is, the data type for the invoice total. Probably it is a number, or probably it is number 93, or it can be float. We don't know. We want the data type for the number be the same as the data type for invoice total. Okay? So what we use here is the percentage sign and then type. Okay? Remember that? Now I'm defining a new thing. I am defining invoice row as this kind of data type. The invoices table, so we have the invoices table. The invoices table has several rows, and each row is a vector of data. So essentially we can say that each row has a kind of vector of data types, or a vector data type. Okay? So I am defining invoice row as a variable, as a vector with the same data types that exist in the invoices table. Okay? And so if we go to the invoices table, let's see. So in invoices table, it's the one row in the invoices table that has number, and then as date, and then number, and then number, and date. See? So it has, actually this is not number, this is text. So varchar, number, so just consider one row. One row is a vector with specific data types. So is a vector that has specific data types for its elements. The elements of the vector have the specific data types. So I am defining the invoice row as such vector. And I am saying that go to the invoices table, see what is the data type for the elements of the row, and take that and define the invoice row as that. So I'm defining invoice row as a row, as a variable that can take the rows of invoices. Here I'm defining invoices cursor as the output of the subquery or query. So the select statement goes to the invoices table and gets only invoices with positive balance, pulls the invoices with positive balance and gets these two values from the invoices table, invoice ID and invoice total, and puts this in invoices cursor. So invoices cursor is a kind of table because it is a subquery. Yeah, because this subquery returns a table. Okay, so remember, the subquery could return many things: a value, a single value, a vector, and a table. This subquery returns a table, and I'm defining the cursor, invoices cursor, as this table. However, a table that is broken down into rows. It is not just a simple table. It is the table that is broken down into its rows. So it is a set of rows. Okay, cursor is a set of rows. And so we have invoices cursor defined like this. And now we go into the for statement. So we have for invoice row in invoices cursor. So invoice row is a variable that we define as the rows of the invoices table. And we are saying that invoice row should go through, should become equal to the members of the invoices, invoices cursor, the members of the cursor. And each member of the cursor is a row. Okay? So then loop, we check if the total, if the invoice total for that particular row in the cursor is more than 1,000, then update invoices and update the credit total for the invoices for that particular invoice ID. You know, so you know, because invoice ID, you can get the invoice ID for of that row here. So I'm getting the invoice ID for that particular row in that cursor like this, invoice row dot invoice ID. I am getting the invoice total of that particular, of that particular row in the cursor like this, invoice row dot invoice total. Okay, so I'm getting these two information for each row, and I'm looping through all the rows that the cursor includes, and then I'm gonna show this message for each row. Actually, this message is showed for each row that is updated, and we only update the rows that have invoice total more than 1,000. The rows, I mean the cases, and in this case means the invoices. Okay, the rows are the invoices. So, and we have end loop at the end of the for. So these are the statements that are repeated for every row in the cursor, every member of the cursor. Okay. So this is what we have here. One row updated by blah, one row updated blah, and essentially 5 times. We have 5 invoices actually in the cursor. We have 5 invoices with invoice total of more than 1,000, and we updated their credit totals. We updated their credit totals. So we are running the updated statement multiple times. Okay. So the loops are very useful for DML commands that manipulate data, like update, insert, and delete. You know, you go to specific things and do that. Particularly update and insert. But for select, you can usually use the where, the conditions in front of where to pull the required information, the information that you need. Okay, are we good? Are we good with cursor? Okay, so you don't want any more examples? No? Yes?
Yes.
Yes.
Yes, okay. So, we don't have much time, but so let's go to another table. Let's go to the products table, or let me see, products table. So we have products, we have 10 products. We are going to go through the products, and if the category, or let's say, make it like this, right, this long description. So if the price is less than something, if the price is less than 500, let's say, if the price is less than 500, discount percent should become 0. How about this? Okay. So we have discount percent here. I want to make the discount percent 0 for all the products that have price of less than 500. That means this one, this one, this one, and this one. So the discount price should become 0. Okay? So do it. Do it. So of course we should use update. Yeah. Updating. If you do it a little bit faster, we can finish varieties as well. And if we can do dynamic queries, that would be amazing. So I'm defining a cursor. Actually, for this particular example, we don't need to use cursor. You probably know that. But use cursor. Actually, there are 4 ways that you can do it. And I'll do it just one way. So what was the price? So who did it? I did it.
I have a question. You said there's 4 ways, right?
What?
There's 4 ways to do this, right?
Yeah, what?
That there's 4 ways to do this problem?
Yes.
So could you have done it where in the cursor you just selected all the ones where price is less than
Yes,
5%?
that is actually one way.
Okay.
Yeah. So you could, so here, what I did was that I selected all the products, so I put the product table into the cursor. Okay? And then here I use the if statement to detect if the product is, the price is less than 500. Right. So something somewhere.
There's a semicolon after the end loop.
After, oops, yes, absolutely. Okay, so it is working. So it did it, and we have, let's see, what we have here. They became 0. 0, 0, 0, 0. Yeah? Okay. So do you want to know the other ways that we can do it? Yeah? Okay. So, okay, first of all, let's roll back. So we have our original values. We have our original values. And the other way to do it is that I'm gonna say, okay, my cursor should be only the products that are like that. It should only be the products with this. Okay, so I'm gonna put this here and say products where the list price is less than 500. All right. So now I don't need the if statement anymore, because I know that the products that I'm concerned with, all those products are here. And I don't need the if statement. Oops. I don't need the if statement. So it makes it a little bit shorter. So if I run it, it should do exactly the same thing. Yeah, it did exactly the same thing. And again, if you go to the product table, you have 0, 0, 0, 0, 0. Okay, so it worked. But let's roll it back again. Let's roll it back again. Let's see. Let's roll it back. Oops, we are running out of time. So the other way around, the other way is that here I have this cursor, so I don't need the cursor and I don't need the loop. Actually, I can say update products where the list price is less than blah, and all the rows that are updated. So there is no loop. Update, and the cursor is not necessary, and this is also not necessary. So just this does the job. Oops. Yeah, it did the job. As you can see, 0, 0, 0. All of them became 0. Okay. However, cursor, you have more flexibility. So, thank you.